My chess game also loaded up there, I think. Okay. Welcome. And as always, we will do the case study first, and that would be followed by a didactic. And today we have a three-part didactic. We have Sendil talking about negative numbers, and then we have Bama who'll talk about Pascal's triangle, and then later by me. So we have two case studies, one by Nadia. I could see her logged in, and so we can get started with Nadia's. Nadia, if you're there, if you can just not necessarily read it out, but just explain the situation to us, ma'am.
Yes, sir. Am I audible, sir?
You're audible. We can't see you. If you can, that will be nice also. Everybody can then see you.
Sir, if you excuse me this time, it will be fine,
No
sir.
problem. Yeah.
Yes, sir. So, good evening, everyone. And so, the case that I've taken up here is I could observe this from last year. So, after whenever we have a break or whenever something makes them to stop working with the math, or I could see who are working continuously also. So they are strong enough in their concepts. So orally they are very clear with their concept, and they are, as we discussed, the three parts: problem solving is good, conceptual uh, things are good, the conceptual base also good. But when we ask them to solve it on their paper during their exams or during their class test, they feel it difficult and they will be blank, and they are giving their papers as blank. So in this case, what can be done? So I was giving them like confidence. They were lagging in confidence when they put the things on paper. So they're very confident when they give it as the oral answers. So I didn't recognize this in the very beginning. As usual, as I started the class with, as it is a new academic year, I didn't feel that this will be a big case for me. So first test has happened, and when I looked into the papers, I could see those who were so active in the class and those who were like, I had expectations on them, but I could see there is a setback. When I check with the kids, I want to make sure that whether they are clear with the concepts and the problem solving skills are excellent. I could say that they are above average. They are not below. I was asking what are when doing everything, why you are not able to do that on a paper. They said like, ma'am, getting she was my
Nadia, I think something is disturbing your mic actually. Can you just maybe...
Yeah, your voice is crackling. Something
is
is
it
close to
fine?
your... Yeah,
Is
better
it
now.
fine now? Yes,
Yeah,
sir.
yeah.
So
It's gone bad again.
one second, sir. In now, sir.
You can pull out that headset
Yes,
and speak
yes,
directly
yes,
into
sir.
the phone. Probably that will
Yes, sir.
help.
I did.
Yeah,
Thank you, sir. So
yeah.
it was like they were saying like, ma'am, we feel like shivering, and we have in our mind like, I want to do it correctly. I want to do it correctly. That makes us to feel like we don't want to do that. Makes us to set it back. Then I told them, when you are confident enough to solve, why do you get it? They were like, no answer for them to put it up. Then I thought in my perception, like, then the lack of practice will make them to set it back. So then I have take it up like every day. They'll be solving at least a question, which will be general as well as from their syllabus. So then I could see a change, a percent of change every month. So that is how I taken it up. If anything else can be done, if you suggest some other strategies, it will be helpful, sir.
Yeah. Thank you, Nadia. That was very helpful and very beautifully explained as to what the situation is. Yeah, that is very clear. Mama Sendel, you want to go? Any clarifying questions at all? Is the situation clear? What Nadia is saying, is that clear? If there are any doubts, we can ask Nadia before we request Bama Sandel to comment on it.
Which grade is this, Nadia? Which grade are you talking about, the child?
Yes, ma'am. It is. I was handling grade 5 as well as grade 6. So I could see this in both the grades. It is not in the large scale, but I have at least five in a class like this who is very clear with oral.
Yeah, then, actually, I don't know. I think that you don't have to worry much. Whatever you're doing, it's good. Giving the child, confidence. And then even if you can initially ask, even if he answers part of the paper by writing, that's good. By the time he reaches 10th, I'm sure he or she will get the confidence to write. I mean, so I think if the slower we go on this and not push the child too much, but at the same time slowly encourage him to write, I think that's really good. I mean, I think you've taken a lot of trouble and to identify this, and I think we have the time to change. He still has a lot of time to.
Yes, ma'am. Thank you, ma'am.
Yeah, thank you.
Sendil?
I think Bama covered it well. And I was also thinking about maybe your topic today could also give some light on this. So we'll probably hold a bit, is what I was.
Yeah, absolutely. I think that's a good point. Yeah, so we can do one thing, Nadia. The topic which we are going to talk about today kind of addresses the problem you're facing. We'll try and take it up and relate to this particular case study itself, where a child who's otherwise pretty okay on conceptual and problem solving skills, the moment we ask the child to put it down on paper, she is not able to put it down. So we can then try and understand what that is. All right, great. Santosh, if you're there, if you can just share your thoughts. It's a little bit of a busy slide. I tried to cut and chop and prune, but still I only ended up with this much.
She will be joining in 10 minutes. Actually,
Or she'll join in 10
Yeah,
minutes?
yeah.
Okay, we'll try and see whether we can take it up at the end. In the interest of time, we'll keep moving forward. Okay, so we have Sendil who will talk to us about negative numbers, then Pascal's triangle by Bama, and later by me. All right. Sendil, if you're ready, we can get going.
Yeah, we can start. Yeah, with the negative numbers, it's something I kept wondering, like, how do we introduce negative numbers to children of maybe 6th grade sometimes, and at sometimes if children are way too young and then they have joined the school quite early, like the negative numbers is not it's not so difficult a concept as such, because of late they
Sorry. Yeah, go on.
sort of they get an idea of what is negative about. So there is an intuitive feeling which comes around and -2 parking. But from a rural point of view, where we haven't really seen much of these things in Tiruvannamalai, so it's a nice thing for us as teachers to ponder about how do we represent a negative number, and so it's very much challenging for us to.
Sendil, I'm having some difficulty hearing you. Do others have the same difficulty?
Is it? How is
Now
it?
it's better. When you
Is
said
it
the is
better?
it? Yeah, much
Yeah.
better. Much better.
Okay. So it is more like how do we explain minus into minus is plus? That's the key thing, I would say. If we are very confident about explaining that in a subjective way, that's all the more best. So before going into the negative to negative, we'll start with, say, can we do something in the movement itself? And we can all have this sort of number line in the class and work on this. So only thing is, many times I see the number line being horizontal, like from moving from left to right instead of left to right. If we can imagine the number line going from almost like front to down, so if we can just front and back, so that way it's very clear for them. So it's just the negative numbers, usually what we say is like moving along the number line is a good idea. But the thing is, when we have the zero and left side is negative and right side is positive, instead of that, just reverse that notion and make it front is positive and back is negative. It's even better if we can have it in a stairs where you see some of the middle stairs as zero stair, and then any steps above that is like positive, and all the others are negative. That's the best actually, if we can have it. Yeah, move to the next slide, Ramesh. Yeah.
Sorry to disturb you, sir.
Yes.
Can I add on a point over here?
Please,
You can
go ahead.
just start by explore. I mean, asking it to students itself. I mean, when I did this, the students came up with a very good example of the lift. So the lift,
Correct,
they're all exposed to lift.
Correct.
Where at a 0 point they're at ground level, and then further they have the -1.
Yes.
So that is a basement. So this can be taken as an example for children to introduce negative.
No, I think you're absolutely right. Actually, when Ramesh said my voice is not audible, I could understand why you're also making this point, because that's exactly how I started also, stating that in cities, children are, it's not that it's negative is completely new to them, though it is introduced in 6th grade and 7th grade. But the thing is, intuitively, they know it because they go to the malls and then see -1, -2 in the apartments. But in rural places like Thiruvannamalai, where I am working now, here there is no possibility of a basement lift and all. And so in this aspect, so how do we bring this notion? But there are stairs and steps in the school where you can use one of the middle steps as 0, and anything above, as you said, is positive, and below is could be negative. So now we draw it on the floor, instead of horizontally, vertically down with 0 in the middle, and then you can have 10 to 12 up and then 10 to 12 down also. You mark those things as positive and negative. And with these things, it's basically now, instead of, say, we have notions here. So there are some numbers in black, and then there are symbols in red. So it is very easy for children to also relate when I say +5 plus +3. So here the difference between, I don't call it as +5 plus +3. That could be confusing for children. So can we be conscious about +5 plus +3? That way they know that from 0 you have to move 5 steps forward, and then if it is plus, you just don't turn back, but you keep moving in the forward itself. If it is positive, you keep moving forward. If it is negative, you move backward. And if it is plus, continue in the same direction. If it is minus, you turn back and move. That's all. So that way we can get the answer. So we'll move to the next one. Yeah, here, so we'll take the first thing as 5 steps forward. It is positive plus positive. So +5, you take 5 steps forward. And then because it's plus, they don't change that. They just facing front itself and 3 steps forward. So this is what they do. So once I introduce this game, almost like 5 children or 6 children in the class, they all stand in the line. And as I call +5 plus +4, they all count it in their mind, and then they keep moving. And sometimes I just ask the class to close their eyes and keep moving, and open the eyes and see if you are in the right place. And they look at the class, and sometimes all of them are in the same place, or in the right place. Some are back, some are forward. It's very interesting to play it in the class with movement.
If I can just add a point, the trick to what Sendil is saying is using the word positive and then plus differently. So he's not using the same word in both places. He's using plus as the direction and the positive and negative as forward and backward. That is very important to know.
Correct. That's the key thing. That's pretty key. Yeah, you're right, Ramesh. Yeah. So if we look at the next example, then we'll clearly know here we are going to read this sum as +5 minus +3. So it's not +5 plus minus +3. That will be very confusing. So if we could clearly say +5 minus +3, for positive, they will need to walk forward. Wherever they are facing, they should walk forward. That's for the positive. And for minus, you have to turn back. But since it's +3, you have already turned back, but you're just going to face forward and then keep walking 3 steps. So they first reached 5, which is +5. Then from there, they took a minus, so they turned back. Now they are taking 3 steps forward as they were facing down. So they reached at 2, and that's where the answer is. So it's also very interesting to see how the class is moving. Can they actually, when they hear a minus, they can turn back, or so that will be nice. We can just say, okay, plus they should not turn, minus they should turn. So we can just play with these values itself and then add the sum. Then it's interesting. Yeah, next one. So here it's -5 plus +3. So if it is negative, they should face front but walk backwards. That's what -5 means. So they keep walking. -5 is like they face just take 5 steps backward, and because they are facing front, because it's plus, now 3 steps forward because it's +3 instead of -3. So now they end up at -2. So that's the one. Next. Now it's -5 minus +3. So -5 is like they take 5 steps backward, and minus is they turn back again. And because it's +3, they keep going down because they took 3 steps forward on the negative direction. So that way they'll end up at -8. So it'll be fun to watch children getting these things and then playing in the class. And it'll be nice to see how many times consistently someone is getting. It's when I've done the class, I was amazed by looking at children who are when I say minus, it's positive, -5 minus +3. Some children would just walk to 2 steps forward or 2 steps backward, because 5 and 3 is intuitively, you sort of, instead of there is a minus, they would do it. But children who are not mathematically so quick, they end up standing in the right place because they just followed the rule you are giving for this game, and they just always win it. And it's just fascinating to see that. Next one. Yeah, here there is no turning back and all. It's -5 plus -3. So always like you walk backwards as it is negative on both things, and you keep continuing as without any turning back. Yeah, and you get at -8. Now it's -5 minus -3. So this is like you walked 5 steps backwards, but you turned back, and then now you're walking 3 steps backward. So you end up at -2. Yeah. Next. Now, how do we do the same thing with multiplication also, the walking? Because it's 2 steps, 3 steps, it's sort of easy. But here, as we do this, keep it to minimum of, say, ×2 or ×3, maximum ×4, like, because we can't keep having a long number line in the class. So with that logistics, just work on that. So here, the thing is like it's minus, the second one is -2, but the first one is positive. It's just the color of the thing. This is the way we should say it. It's 2 times after turning, it's +2 times -2. That's how we say this thing, just like the previous one. So you just 2 times turning around is like, again, you will come back to the same place and you just walk forward. So you turn around and then you do the 2 steps forward twice. That's what it means. You take 2 steps forward anyways because it's positive, but you have turned back and then you are doing it twice. That's the whole thing. Yeah. Next. Here it's -2 and +2 times. So which is, you don't turn back, but the -2 which you will walk backwards, you have to do that twice. That's what it means. Yeah. Next. Here is it's -2, but you have to turn back and then do twice, which is -2. -2 -2, which is you turned back and then -2, you will walk backwards. Because you turned back and then you're walking backwards twice, you end up in a +4. And that's what it means. Yeah. Next. This tray method is something very interesting for me to look at. Here, the key thing is, I'll tell why this tray method is interesting. Because to show what is minus into minus is plus, is it like, and how do we explain this? Do we gain more from minus into minus to get plus? That's the key thing which we will look at in this tray method. So we'll see it. So you have two sets of cards. One is like positive cards and then negative cards. Have as many. I'm just stating is at 20, but you can have many cards as well. So let's consider like it's more like a coffee, tea tokens or something like that. Different colors you have it in the tray, and but arrange it in such a way that it's easier for us to count. Let's look at the next one in the next slide. So here, what it means in the tray is, say you could count there are two purple cards and then four blue cards. That's what it looks like. Okay. So, but the thing is, initially, as you start, have equal number of cards on both things. Have equal number of negative, equal number of positive, which is in the tray already. Okay. Now for +3 times +2, like that. So you have to add 3 positive cards twice. That it means. So you add that in tray. Now have some token outside also, but whatever in the tray is equal as you start. Now you add 3 positive cards twice, which is 6 positive cards. Now you just count how many more is, which one is more and how many more. So the positive cards is more than the purple cards and it's 6 more. So you get answer as plus 6. Similarly for -3 times 2. So for that, you're going to add negative cards twice, 3 set of cards. So that becomes, so which is more? It's actually the 6 negative cards is more. That way, the plus into minus or minus into plus is addressed. Let's move on to the next one. Here is the last one is the interesting one. Say, last time we added into the tray, but now we are going to take out from the tray. So have more in the tray these times. But when you have more, have equal number of positive and negative cards. That's the key. Don't leave that. So if you have equal number of positive and negative cards, now you're going to take away twice 3 positive cards. That's what the first one means. So +3 times -2. So you're going to take away some of the positive cards. So what you end up is having 6 negative cards, which is more than the positive cards. So -6. But now comes the very interesting part, whereas you are going to take away 2 times 3 negative cards. So what you are going, when you take away these things, what you end up having is more positive cards because the positive and the negative was equal when we started. So we have 6 positive cards. It does not mean that we got 6 more. Actually, we are left with cards which are, it just means that we are having 6 less of negative cards. That's the main thing. That's how it feels. It is the minus into minus plus is more a notional thing. So to understand that, have equal set of cards. That's what it means. Here is one example also. It's in the next slide, I guess. So that's the W. Sawyer's book, Mathematician's Delight. He was talking about one of the examples which he would give for how to look at this negative into negative. So he said, you can consider it as a traffic fine which you've got. Say you got some 5 traffic violations which came to your door. So the moment you see the traffic violation as say 500 rupees per violation or something, right? And then like you have 5 of that. So you may have to immediately you see it, you consider that your account has been debited or they took the money of 2,500 rupees. But the next day the postman is coming and then saying that, oh, I should actually deliver the fine bills to the next your neighbor, but I accidentally gave it to you. So give those fines back. So now he is going to take away the bills which you have paid for, which in a way you will get the 2,500 rupees back to you. So you are gaining 2,500 on the next day when he is coming and taking away the fines from you. The fines is a negative thing. He is taking away the negative. So you're notionally positive of 2,500. That's what it means. So that could come from the tray method is what I got. Yeah. Next. Next. That's what I
Uploaded
was
it.
mentioning. So here it talks about the same thing. Yeah.
Yeah.
Yeah. This is the same thing. Here he talks about the takeaway 4 bills of £5 each. That's the thing. So when the postman talks about that, it's exactly the notional positivity is the key thing. Yeah, to have that, it's actually like just like your account will have monies, so the tray will have positive and negative cards too. So taking away negative cards is actually taking away some of the fines which you are not supposed to pay. That's why you feel positive about it. That's why you feel the balance is always positive. So here, as it says in the slide, -4 times -5 is +20. You are not getting 20 more, actually. You are just not taken 20 away from you, which itself is a positive thing. Yeah. Yeah. Thanks, Sumesh.
All right. Super.
Yeah.
Thank you. Thank you. I was also thinking if we describe it as get a good thing, get a bad thing, take away a good thing, or get take away a bad thing, something like that also. I mean, we can imagine what that bad thing is and then try and describe it also, which is that get a
Oh,
good
I
thing
think
with,
you're right. That it
yeah,
is correct. Yeah, taking away
get
some of your bad things, you feel positive about it. Yeah. It's a
yeah,
notional uh, profit for you. That's how it looks. Yeah.
yeah, something like that. Yeah. Okay. Thank you, Sandhya. And now we'll take the questions at the end if there are any. And we can move straight to Bama's bit. Bama, if you're ready.
Yeah, thanks, Ramesh. Next, please. So last session, we looked at fractals and we saw that they were so beautiful and fascinating. And Pascal's triangle has a similar effect on us because it's a treasure trove of so many patterns and secrets. And the triangle itself is very easy to create. And if we give this pattern that is shown on the left as a puzzle to children, and you ask them the rule, like what is the rule to fill up the rest of the hexagonal, the blank spaces. So in all probability, the children are going to be able to find that out because each number is just the sum of the above two numbers. So it's very simple. Next, please. So we start with a 1 and then we assume that there are zeros on either side of it, and that is the first row is considered the 0 row, okay? And then the next row we get by adding the two numbers above it, so we get two ones. And then the second row, again we add the two numbers. The side we assume they are all zeros, so the second row we get 1, 2, 1, and so on, it just gets filled up. So this is very easy to create. It's just addition, right? And we can give these with a fewer number of rows to smaller children and then ask them to fill it up. But then the content it has, it's just totally amazing. All that we can find out from this Pascal's triangle. So this triangle has been around for a long time. Even like 1,000 years back, Indian mathematicians called it the staircase of Mount Meru, and it's also called Khayyam's triangle after the mathematician Omar Khayyam. And then the picture on the left is from a Chinese book written in the 14th century. So all these different, civilizations, we have all found this out. But then Blaise Pascal, he wrote a treatise about it just in the 17th century, quite recently, compared to the others, and with several known results. And he used this to solve problems in probability. And so that's why it's called Pascal's triangle. So let's see what all we can do with this, and it over a different grades, we can give different kinds of problems to children. So we can start off with asking children to create the Pascal's triangle and look at the patterns it has. So first, of course, it has a vertical symmetry as shown on the top left. And secondly, it has like the outermost line numbers are all ones. Okay, and then the yellow diagonal is a set of natural numbers. You have 1, 2, 3, etc. goes on, and then on the next diagonal, it has a set of triangular numbers. So what are triangular numbers? Next, please. So triangular numbers are something that children relate to very easily. So these are the number of dots or stones that can be arranged as a triangle. So we can do this with carom coins or anything circular. So the first triangular number is 1. The second one is 3, because you can use 3 circles to make a triangle. The third one is 6. And so on. So basically, the nth triangular number is, we have to add n at the base, right, to the n minus 1's triangular number. So one thing is, we can say the nth triangular number is the n minus 1th triangular number, Tn minus 1 plus n. Next, please. Further, like, the first triangular number is 1, the second is 1 plus 2, the third one is 1 plus 2 plus 3. If we put it like this, the nth number is nothing but the sum of the first n natural numbers. And so for this, we know we have a formula, right? So, we have the story about Gauss also, who found this property. So we have Tn, the nth triangular number is nothing but n into n plus 1 by 2. And with this formula, we see that if we arrange the nth triangular number taken 2 times side by side, right? So the first triangular number, you take it 2 times side by side. Or the second one, 3 and 3, you take it side by side. It forms a rectangle. The dark blue and the light blue. Again, the third triangular number is 6. Again, 2 of those 6 and 6 of these circles, you can arrange it, you can form a rectangle. So this is nothing but the area of the number of rounds or circles in this rectangle is nothing but n into n plus 1, right? Because it's a rectangle. So, and since you've taken 2 of these, it's nothing but n into n plus 1 by 2. So just by arranging these circles or these little pebbles or whatever you use to make these triangular numbers, these properties can be understood very easily. And another very popular property of the triangular number is, when we arrange 2 consecutive triangular numbers as shown, they always form a square. So T2 is 3 and T3 is nothing but 6. You arrange it, you can make a square. And that is nothing but 3 squared. So again, T3 is 6, T4 is 10. You can arrange these spheres to form a 4 by 4 square. So basically, Tn plus 1 is nothing but n plus 1 whole squared. Next, please. And this can be seen so beautifully in the Pascal's triangle. The square of any natural number, right, is nothing but this. You can see, can be adding the triangular number next to it and the triangular number just below it. So 4 squared is nothing but 6 plus 10. And 5 squared is nothing but 10 plus 15, that is 25. So this property can be seen in the Pascal's triangle. So after the diagonal showing the triangular numbers, we have the tetrahedral numbers. And what are these? So this is shown in gray over here. This is nothing but you extend the triangular numbers into the third dimension. So basically, if you arrange the triangular numbers one above the other, we get a pyramid, a triangular tetrahedron, yeah, triangular based pyramid. And this, so for example, the tetrahedron of height 2 with the first two triangular numbers is base is 3, and then you top there's one ball. Or the next one is base is 4, and then on top of that we have 3, and then we have 1. So like this. And the number of this we can, that sum of the first n triangular numbers is the nth tetrahedral numbers. And these can be again seen by the next diagonal in the Pascal's triangle. So now let's look at some more patterns. Right. So if you add up all the numbers in each row in the Pascal's triangle, we get the successive powers of 2 as shown on the left. So we have, if you take the fourth row, for example, you sum it up, you get 1 plus 4 plus 6 plus 4 plus 1 is 16, and that is 2 power 4. And then you have 2 power 5 and so on. Next. And not only that, if you take each row's digits as they are, like you consider the place value also, right? The ones place and then the tens place next to it and so on, you have the powers of 11 comes out. So you have 1, that is 11 power 0, then 11, 11 power 1, then 121, then 1331, 11 power 3, and so on. And even it still holds up, even you start putting numbers like 10 and so on, because in the fifth row, for example, you have 1 into 10 power 5 plus 5 into 10 power 4 plus 10 into 10 power 3 and 10 into 10 power 2 and so on. You add that up, you get 161051, and that is nothing but 11 power 5. So this, it's perhaps really a nice property, amazing property in Pascal's triangle. And we can have this activity when we teach children primes. That is, the prime numbers, they are all on the first diagonal, of course, because we have the set of natural numbers on the diagonal. And here I have circled them in red. So all the prime numbers, right? So then if you consider a number that is prime, you look along that row. Okay, not including the first and the last one. So all the other numbers are all multiples of it. For example, 11 is a prime, right? If you look at that row, we have 55, 165, 330, 462. These are all multiples of the prime number 11. So a number is prime if all the numbers along that row holding the prime are exact multiples. Actually, it's if and only if. Yeah. And the converse is also true. Yeah. So a number is composite if there exists at least one number along that row, which is not its perfect multiple. For example, 8 is not prime, right? And so along that row, we have 28, 56, and 70. And out of this, 28 and 70 are not divisible by 8. So 8 is composite. This is a lovely example, right?
Yeah.
Lovely property.
Yeah. Amazing.
So then you have all of you must have heard of the Fibonacci sequence, and also present over here. And we start off with 0 and 1, and then we draw these shallow okay, what are Fibonacci numbers? They are like F0, the first 0th number is 0, then F1 is 1, and then you keep adding the previous two numbers. So Fn is nothing but Fn minus 1 plus Fn minus 2. So we have 0, 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on, right? And these are found because when we just look at these kind of diagonals as shown in red, those are also what we call as shallow diagonals. And then we add the numbers along them, we get the Fibonacci sequence. So we can have activities. These are all, many of these activities are for middle schoolers and high schoolers. Maybe more middle school, high school will come later. But these kind of coloring activities for small children, they enjoy a lot. So for example, if you color all the odd numbers one color and the even numbers another color, we get the Sierpinski triangle fractal, what we saw in the last time. And similarly, we can, I mean, I haven't shown them here, but then we can color different things, like color multiples of 5s, multiples of 4s, and we can see the patterns that we get. Very, very nice, very colorful patterns. We get really stunning designs. And so we can, enforce what are multiples, the subtraction, 1 less than the multiple of 5 on one color, 2 less than the multiple of 5 in another color, and so on. So we reinforce our counting skills and number skills, number sense, and these are all fun activities for kids. This is another, again, a really fun activity. It's called the stick pattern. So you ask children to start at any one, okay, at the ends of this triangle, and then you traverse the diagonal to whatever distance he or she wants, and then turn the other direction. And the sum of all these numbers traversed will be equal to the number in the other direction. So for example, I start with 1, and then 3, and then 6 along the diagonal. 1 plus 3 plus 6 is nothing but 10 as soon as you turn. So again, 1 plus 6 plus 21 plus 56 plus 126 plus 252 is 462. With the point you turn, it's a number right directly before it. And this at least is very easy to prove, because 462, we know it's a sum of the other two numbers, like 210 plus 252. And then again, 210 is again the sum of 84 plus 126. So you keep going backwards, and you can prove this property quite easily. So now we come to activities for the older children. So we can, like here, the number of ways of different coin tosses is hidden in the Pascal's triangle. For example, how many ways can I get exactly 2 heads from 4 coin tosses, say? Okay, the number of coin tosses is the row number. So we have to go to that particular row. So row 1, forget row 0. Row 1 means I'm tossing the coin once. Okay, so I can get either a head or a tail. And this is shown in row 1 as 2 ones. Okay, there's only one way I can get a head and one way I can get a tail, because I have just one coin toss. So now have row 2. Okay, this indicates 2 coin tosses. So the possible outcomes are both are heads, right? Both the tosses, or I can get 1 head and 1 tail, or I can get 2 tails. And so there is only one way to get 2 heads, both of them, both the tosses. I can get a head and tail in 2 ways. The first toss can be a head, the second one can be a tail, or the first toss can be a tail, the second one can be a head. So 2 ways. And finally, one way by which we can get 2 tails. So the second row, the row numbers indicate this: 1, 2, and 1. So similarly, the third row, it shows us the number of the ways I can get all the possibilities with 3 coin tosses. So if I can have 3 heads, only one way, all 3 tosses are heads, or I can have 2 heads and a tail. There are 3 possible ways, because you can have HHT or HTH or THH, and then 2 tails and a head, again 3 ways. TTH or THT, and then 3 tails. There's only one way. So you can continue like this. So basically, suppose I want to calculate the probability of getting exactly 2 heads in 4 coin tosses. We look at the 4th row, right? So for the 4 coin tosses, and the number of ways I can get exactly 2 heads is 6. Okay, and so that divided by the total number of ways. Total number of ways is just 2 power 4, right? Each coin toss, there are 2. So 2 into 2 into 2 into 2, so 2 power 4, so 16. So the probability is 6 by 16. So actually Pascal used his triangle to calculate probabilities. And so similarly, you have combinations all hidden over here. So if I have n things and I want to choose R of them, how many ways can I do it? That is NCR, right? So, for example, if you're in an ice cream shop and you have 5 flavors of ice cream, how many ways can you choose 2 flavors? There are 5 different ways, and I want to choose 2. And so we have 5C2. And in Pascal's triangle, if I look at the 5th row and the second number in that row, okay, we get that. So what is 5C2? We know we have that, we have factorial n by factorial r by factorial n minus r. Basically, n things take an r at a time. And so where n is the row number and r is the rth entry in that row. Start again with 0. We count everything here from 0. And so again, Pascal used this to calculate probabilities, combination values, and since the calculator was not there those days, you just have to make up the Pascal's triangle once, just additions are involved, and all these things are all hidden in this. So we have all the combinations, and then now we know that the coefficients of the binomial expansions are all present in it, right? Because what are the coefficients of the binomial expansion? Nothing but NC0, NC1, NC2, and so on. So nth row corresponds to the coefficients of that expansion. X power x plus y to the power of n is nothing but, suppose I have x plus y to the power of 4, we have x power 4, then 4x cubed y, 6x squared, y squared, 4x y. So all these numbers are just there in the 4th row for us. And also this is a very cute property. It's called Pascal's petals. So once again, this is based on your combination NCR because that's what Pascal's triangle is made up of anyway. So if you take any number in the inner part of the triangle, it is surrounded by 6 numbers, right? Like the petals of a flower. So in this, the product of the alternate petals are equal. So in this example, if we consider the number 15, it is surrounded by 5, 10, 20, 35, 21, and 6. And in this, if we find the product of the alternate numbers, so 5 into 20 into 21 is 2100, and 6 into 10 into 35 is 2100 again. We find that they're equal. You can try any numbers. And the proof of this, it directly follows from the combination seen earlier. Like, because we can expand this n minus 1 cr minus 1 into n cr plus 1 is into n plus 1 cr. So if we can just write it out as factorials, and we can prove this quite easily. So yeah, so basically, the thing is, if we give them same type of additions, subtractions, multiplications, all these as homework or in classes, where all these procedural things again and again, the children, they just get bored, right? So instead of that, if we give them activities with this kind of a triangle or with the fractal, or so with and where again the same operations we can again do it, but in a nicer way, in a fun-filled manner. So that is sort of it gets them interested in math. It brings out the beauty in math. And actually math is it's just patterns. They say one way of defining math, it's like it's filled with patterns. So maybe kids can get attracted to math. So yeah, it makes our math classes more engaging. Thank you.
Awesome.
And yeah, there are more. In fact, they are saying they are still finding patterns and new properties in the triangle apparently. So recently they found something like a plus b plus c etc. to the power of n. If you extend the binomial expansion. So, and that's how amazing this triangle is. Thank you.
Thank you.
Hello. Excuse me. Yeah, here the whole of what Bama spoke about today is all can come under one topic called wonder of maths, wonder of numbers.
Yeah.
And I could also see it does not really
Getting cut. Yeah, Senthil, we can't hear you.
We can't hear you, sir.
We can't hear you, Senthil. Sorry.
Is it audible now?
Not
Slightly.
quite.
Yeah.
No. Yeah.
Now
So
it is better. Yeah.
if, I was just wondering the hockey stick pattern. So
Yeah.
it like a stick, it changes direction only if it is an odd number row, and if it doesn't really need to change if an even number row. So that's also nice. And there are many other things. As I was looking at the Pascal, we know, say I give the first two numbers as 1 and say 41. And what could be the next series of numbers? That could be a very interesting floor kind of a thing. It's just fascinating. Nice.
Yeah,
And
but this odd number, even number, why are you saying? I mean, I thought it works for everything or
no,
something.
you look at the it just works.
Uh,
If you go to the slide, you can see that it also works with changing direction also. So go
yeah,
to
yeah,
the
yeah.
hockey stick thing. It's
Yeah.
yeah. 1, 3, 6, and 10 can just be on the fourth thing, because that 1, 5, 10, 10 is actually the sixth row, right? So it's an even number row. It can just go in the same direction even without changing also. What you're
Oh,
saying is
yeah,
right.
of course.
As
Yeah,
it
yeah,
is,
yeah,
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 yeah.
yeah,
Agreed,
yeah.
agreed. Yeah, yeah, yeah. Even number row, we can do that. Odd number, we have to
yes,
change
yes.
direction because the center number is, yeah, correct. True.
Correct, correct. Yeah.
And the changing direction is not left or right, it's always down.
Yes, yes.
Yes, yes, yes. Downwards,
Yeah.
yes.
Yeah. All right, cool. Thank you, Bama. Thank you, Sandil. Now we have, well, close to about 20 minutes I will take probably, and then we will have to allocate some time for Santosh. Are you there? Okay.
Yes. Yes.
Okay, okay. We'll come to you because we were trying to address your case earlier. We couldn't because you had not joined in by then. I just wanted to be sure that you're there. Okay. Now, use your chat box and quickly type out your, the word which comes to your mind. Don't overthink it as the opposite of success. Can you use your chat box and just write down the word which comes to your mind, which is the opposite of success? All right, wonderful. Now, Pushpa, Anjana, Meeta, Santosh, I want you to give me a hero you really admire, somebody you really admire.
Sir, opposite of success is experience.
Opposite of success is experience. Maybe, yeah, we'll come to that. Okay. Now, leave out the opposite of success now. So can you write down the name of any hero, any person who's your hero? Somebody whom you greatly admire. Yeah, we are done with that exercise, Shanmugapriya. Just write down the name of anybody who is your hero. Somebody you really admire. Okay, Dr. Abdul Kalam, Swami Vivekananda, Malcolm X.
My father and my mother, sir.
Father, teacher. All right, great. Now, these are the questions we need to ask, right? Let's take any one example here. We could take, specifically father, mother, we won't be able to say or comment. But if you take somebody like Vivekananda or Malcolm X, or let's take the example of Dr. Abdul Kalam, has he met with any failure at all? As in, were all the rockets he launched successful launches? Or did he have any launches which didn't go as expected? In which case, can we call Dr. Abdul Kalam as a successful person or as a failure? Because if we say something is success and the opposite of that is failure, then we should be able to say that something which is success, okay, the opposite of that should be mutually exclusive. Okay, it should not contain that. If in the case of Abdul Kalam or in the case of Malcolm X or Swami Vivekananda, if they've had situations where they have failed as well, the opposite of success really cannot be failure. Now, there is definitely an opposite of success. And that opposite of success is giving up. The one time you can be absolutely sure that you cannot succeed is if you are given up. Okay, that is the opposite of success. Once you have given up something, then there is no way of achieving it. That much is clear. But when you fail in something like that, what happens is failure has to be treated as an integral part of the process of succeeding. So those are setbacks, those are speed bumps we meet on the way. In the process of succeeding, failure is very much a part of it. But when we define success and failure as opposites, there is a problem. Now, the problem really comes. Now, I want us to keep relating back to the problem which Nadia was talking about at the beginning of this conversation, where she was saying there are children who are pretty decent and above average when it comes to conceptual and problem solving skills. The moment I give them an examination or a test, they completely freeze and they are unable to write it and put it down on a piece of paper. Okay, I want us to keep relating back to that. Now, if the opposite of success is failure, then if we define it that way, what happens is the moment we don't succeed, we start giving reasons. We start giving reasons and blaming external circumstances or something which is outside of us. Why? Because we don't want to take accountability for failure. Why? Because if I take accountability for failure, then I'm not successful. You see, all of us would like to be successful. But if we just say success and failure are basically a part of the whole process of trying, and the opposite of the process of trying is called not trying or giving up, if we define it like that, okay, as did I try or did I not try? When I say I try, I'm going to call that as, successful because it has success, it has failures, but eventually I have my opportunity to be successful is even there when I try. But if I look at it as not trying, which is the other side, then I can be very, very sure there is no chance of being successful because I'm not even giving it a shot. Okay, the child who's not even putting it on a piece of paper, her answer or his answer is unlikely to get any marks. But if you put down something, okay, it might be right, it might be wrong, it doesn't really matter. If you put down something, then there is a chance we can fail, we can learn from it, and we can slowly try again and become successful. Okay, so it's critically important that as a classroom, as a teacher, we inculcate that in our classroom and bring about an attitude of failing. Okay, having the complete acceptance as a classroom when something is not the right answer, when something is not done the right way, it doesn't really matter because that failure is something. So all we want to do is we don't want to end up wasting the failure. Okay, if we can learn a little bit from that, it's great, but we should not also overemphasize saying that every failure is an opportunity to learn and all that. Failure can just be taken as failure. It doesn't need to be emphasized. Kids will naturally know next time around, I won't do that. Okay, there is no need to moralize at that point in time. If they try something and it doesn't work out, they know that it's not working out and I have to try something else. Okay, that learning is almost automatic in a failure most of the time. So therefore, it's important that we are able to teach our kids not just to succeed, but they need to learn how to fail. And that's very, very, very important when it comes to the later part of their life, when they are in the real world, when things are not going to be structured problems and things are not going to happen as they hope it to be. And therefore, it's very important. So we are not talking about saying that, get into an attitude of saying, it's okay if I keep failing, it's not a big deal. We're not talking about that. We are talking about having the attitude of saying that if I have to succeed, I have to necessarily fail a few times. Once in a while, I might get instantaneous success, that's fine. But many times we start something, doesn't work out, we come back and try again and try again and try again. That is the attitude we want to give, not giving up completely. Okay, why is it so difficult to fail? The first thing is, we as a society, as teachers, as parents, as an overall group of people, we do provide verbal and non-verbal cues to our children, which is a social cueing, which says, this person is a failure or that person is successful or any of those things. The moment we start labeling, the moment we start giving either verbal or non-verbal cueing, it immediately starts creating that gradation inside the head of a child. And the second reason is, we don't end up giving enough opportunities to fail. We'll talk more about it as we go forward on that particular part. Let's go into social cueing. What do we mean by social cueing? So one is, we say math is a subject of exact answers. You're smart only if you're good at math. Okay, if you ask somebody, I mean, is Virat Kohli very good or smart? You'll say, oh, Virat Kohli is a good cricketer, but if smart, I really, because what we mean is smart, we implicitly mean good at mathematics or good in physics or chemistry or one of these sciences, so to speak. And third, when it comes to our marking, we always mark our exam paper for the right answer. If you start marking for the thought process, at least in the internal tests which we have, if you start marking it for the thought process or the approach the child is taking, it might create a very different attitude towards examinations and tests itself, because the marking is not going to be saying that, you know, you're an A or a B or a C or a 90% or a 70%. It's not any of those things, but it's a very progressive way of marking, saying that let's all try and understand together as a classroom how far we have traveled, so that if there are anybody who have not traveled enough in this particular journey, we can spend a bit more time so that we all connect back. So it's like a traveling, right? I mean, it's like when we go for a class, not picnic, those outings when we go. So we will always say, okay, let's leave the dorm room and then we will all convene in one place. After that, we go and see this. At 10:40, we come back and convene in another place where we'll sit down for a drink of water. And then we travel for another 1 hour and then we convene in another place. Along the way, we can go in different directions. So similarly, tests have to be thought of like that, as a place where we reassemble all the children and the entire classroom reassembles. And if some of them are left behind, so we have to figure out a way that they can also join the group so that we can keep moving forward. And in that respect, it's important we don't end up labeling the children. There will always be children in a classroom who are, raising their hand for every question you ask. Okay, they are naturally more curious and they're naturally more proficient in that particular subject called mathematics. So as long as we see that as a subject in perspective and say that, well, this particular child seems to have a natural aptitude or has an aptitude for mathematics, has an interest for mathematics, that is fine. And there will always also be children who will be struggling in that particular subject, and that's fine as well. And it's absolutely not necessary to segregate children as fast learners, slow learners, and so on and so forth. And there is a video I will share in this particular group, which Sendil was talking about, what is called compassionate pedagogy. And some of those ideas get spoken about there as well in terms of segregation. Because what happens when we don't teach them how to fail is, the first response is defending the existing position, which is, if I've got something, I defend that particular position. And one way of defending a particular position is not taking a risk to move from the comfort zone into a place of discomfort, into a place where I can potentially fail. So I would rather give up success and not try as compared to trying and failing. That's a huge problem. We don't want our children who would say, I would rather give up than trying and failing. Okay, I would rather give up as compared to trying and failing. If I try, I can be successful, but that's okay. I want to give up taking the risk itself. And that risk avoidance is a big, big problem, which we should not have in our classroom. And there are certain ways in which we can do that. One of them, the second one, is we talked about opportunities to fail. Are we giving our children adequate opportunities to fail? Are we giving them enough opportunity to struggle cognitively? But when we are in a rush to complete the syllabus and say we have to do this and this and this, the space between the question and the answer, the space for cognitive struggle gets shrunk, becomes shorter and shorter and shorter and shorter and shorter, to the extent we literally come to a class when we have to add two fractions, and then we say, look at the two numbers at the bottom, the two denominators, and we have to take an LCM. The entire process of discovery of a least common multiple is completely taken away, and we jump into an idea called LCM itself. The second one is convergent thinking. We'll talk a bit about it. And then finally, the didactic contract. Okay, what is convergent thinking? Convergent thinking is asking a question like this. How much is 8 plus 5? All kids can answer that. If the two angles of a triangle are 75 and 45, what is the third angle? You get the drift. These are called convergent questions. The length, breadth, and height of a particular cuboid is A, B, and C, and what is the volume? Okay. Now, these are all questions which are called convergent thinking questions. They narrow our path towards a particular answer. It's like a funnel. It just goes inside, and then out comes a singular answer. Now, then in which case, what is divergent thinking? Let's ask this question to a classroom. Actually, try this as a classroom and see how the response is. We'll be very happy to hear what if you can go back and do it in your classrooms and come back and share it the next time around, it'll be wonderful. Okay. The question could be something like this. The sum of two numbers is 13. What can the numbers be? Now, there will be a child or some children will start by saying 1 plus 12 or 6 plus 7. Or 7 plus 6. And slowly you can list down all the numbers. Okay. Once you have listed down all the numbers, you would realize the one the children would have missed out would be 0 plus 13 and 13 plus 0. More often than not, that gets missed out. And now I'll tell you another combination which you might have also missed out. 1.5 plus 11.5 is 13. Okay, and now we slowly discover through the divergent thinking process that there can be infinite ways two numbers can add up to 13 itself. Similarly, the other questions also we can structure. If one of the angles of a triangle is 75, now you get the drift of how to structure a question like that. So we won't spend much time and move on. And the last part is what is called a didactic contract. As a teacher, we implicitly believe that it is very important for us to, quote unquote, teach the child. We implicitly assume the child will not naturally learn, and there has to be an external force, which is why our classrooms are bound by four walls. They're all asked to sit inside that. So because we implicitly assume the children don't want to be there. Okay, we bind it on all four sides and then provide some rules like being quiet and stuff like that, because we create all those artificiality. The implicit understanding and thinking we have behind it is we somehow think the children are not naturally curious to learn, and therefore I have to teach them that particular subject. But what is really important or to be understood is that children are naturally hungry. And that hunger level has to be elevated by way of how we introduce a topic. And once the hunger level is reasonably elevated by introducing a certain topic, then we have to feed the hunger. Okay. Now that feeding the hunger is about getting that curiosity raised and slowly, unraveling the whole mystery and that suspense and everything else. It's a bit of a showman kind of an idea here. And we have to slowly unravel it and slowly bring about that process of discovery for the child. And wherever possible, we should take the backstage where we are not opening out that unraveling part of it, or the opening of that particular gift should not be done eagerly by us. As a didactic contract, what we have is we have the tendency to teach, and in the process, we might be over teaching. Okay, so the idea is to allow the class to discover rather than we telling them what it is. Give them the cognitive struggle, almost never answer a question. Okay, whenever there's an interesting question, the answer, remember, answer is a dead end. There is no thinking after an answer. There is only thinking, there is only joy, there is only beauty up to the time when we get the answer. The answer itself is not relevant in a classroom. Okay, we can show a puzzle, we can describe it, we can think about it, we can discuss it. All of that action will be there. And we can observe it in a class. All that action and the curiosity and the energy and the cognitive struggle, everything will be there till the point the answer is given. Give the answer, that's a dead end. After that, there is nothing to try, nothing to feel good about. Okay, it's a good answer, it's a right answer, big deal. Okay, so it's important we have that cognitive struggle, and we have to have a culture of making that struggle joy. Okay, so the most important thing for a student, therefore, is having the opportunity to fail and make mistakes. And for that, the class environment has to be very, very accepting, rather than saying you're bright, you're smart, you're intelligent, you're dumb, you're like this. Or even for us to believe, it is enough for a teacher to believe that this child is smart and this child is not smart. That's enough. If you have that belief, we will show it non-verbally in a classroom, and most of our children will be able to pick up the emotional cues we are able to give them. So we have to fundamentally, deeply, intrinsically inside of ourselves believe that all children can learn mathematics, but some of them will have to fail a little bit more to get to the success, and some of them will get to success with lesser number of failures. But failing itself is not at all a problem. Different children will fail different amounts, and they will all come out successful at the end of the day. But the one thing we don't want our children to do is to give up, right? Give up or develop a hatred for the subject and say that I hate mathematics, or I don't really want to do mathematics anymore. So as a teacher, need to deeply believe in some of these things. I'll skip the slide pretty quickly. The last point is very important, which says that remember, as a teacher, you're not a sage on the stage. We're just a guide on the side. The process of learning, the curiosity is already there in children. And they are naturally curious. As teachers, the only thing we have to do is to somehow nurture the curiosity and show them more things they can get curious about. You show something like a puzzle or a game or Pascal's triangle or any of these things, turning around negative numbers, just keep showing these things as new discussions which get started in a classroom. And the process of discovery, the curiosity will take them through the process of discovery. When the process of discovery is not happening or hitting a dead end, you can slightly guide it, but not be very eager. Okay, so the trick is to have a noisy classroom. The class is discovering everything. And as a teacher, we play as little a role as possible for the classroom to discover the whole thing. Okay, so as a teacher, the first thing is you should not think of it as a right answer or wrong answer, and definitely not equate wrong answer to bad at math. Okay, it just means that who tried and who did not try. If you just mentally rearrange and think of it not as right and wrong and right answer, wrong answer, successful and unsuccessful and failure, just reorient ourselves and say, I'm just going to think of it as my classroom, my children as triers and giving up, the children who are giving up. And I want to know why children are giving up. I don't care whether they are good in mathematics or not. I want to really deeply understand why are they giving up? What is that I can do as a teacher so that they don't give up? If they just learn how not to give up, success will come. That's not a problem at all. Somewhere it will come. We don't know where it will come for every child. It might not be in mathematics, it might not be in science, it might not be in art, it might not be in sports. We don't know where it will come, but somewhere it will come. Yeah. That's all we have. we can go straight up to Nadia. Did we answer some of the things you brought up, Ma, at the beginning? Nadia? If you're speaking, we can't hear you. You have to unmute. Oh, maybe she has left. Nadia, are you there?
Yes, sir. Yes, sir. Now I
Ah.
got it, sir. So success, it is not like even the child is being done to some extent. So I should appreciate it. It's not like I should expect them then 100%. So they'll be going, at least if they try also, that's a success of the child.
Correct, correct. So exactly. So the focus as a teacher for us is whenever a child gives up, I want to do something about it. Okay, I want to do something about it, not in an interventionist way, but in an understanding way, in a compassionate way. I want to know why the child is giving up. The right answer, wrong answer, they will come and go. Okay, in this particular thing, when the child is doing a class test itself as a trick, because sometimes it's also the anxiety the child might be going through. As a trick, whenever this particular child or this group of children, when they raise their hand and answer that in a classroom, and they're answering it right, tell them, why don't you write it on a piece of paper and show it to the whole classroom? That is just to take away the anxiety. Okay, that's like taking out the stage fright. That is not the solution. Okay, to take out stage fright, people say, imagine everybody as a monkey or something like that. But that's not a solution by itself. I mean, it's a lousy solution, but it kind of takes away that anxiety part of it and the nervousness part of it, rather than just coming into the examination and given a paper and where they're freezing, just ease them into it. Okay. If you have a fear of
Yes, sir.
flying, for instance, just mentally preparing ourselves for 2 or 3 days before the flight is taken, it usually works. Okay, it does slowly get the anxiety out of the way. All right, thank you, Nadia. And Santosh, we have 10 minutes, Santosh. So you can go ahead and describe some of the things you have mentioned there from the last session. And it would be nice if you can talk about 1 or 2 or 3 of these. Santosh, go ahead, man.
Ramesh, in the meantime,
Yeah.
so it's just, I was just looking at, is there a word for something like this, a fear of failure? And then I came across this aticophobia. They call it as fear of failure, and probably imposter syndrome is also something very similar, but distinctly different also as well.
Yeah.
But the thing is, why someone is having this fear of failure? If we look deeply, the possibility is, are we having a common expectation for the whole class, which has varied skill set and varied strengths? So when the strengths and their capacities are varied, they should only try to get a little more from where they were earlier. That's what is the path to success. Is like, once you fail, you keep going 2 steps ahead. You're not going to have to reach, say, 100 meters and all same for the whole class. That's when we are really feeling unsafe. So it's not that the class is unsafe because there is someone with a stick, but these sticks are the unnecessary expectations for children, which is not really expected from us. But can we clarify the expectations outright clearly, to because it's the expectations are different for each child in the class? And so creating safe spaces is more important for us to, as you were saying, can you write it and then give? That's just in the compassion of, in the interest of the child, we understand the child, so we do it. It's not a tactic to get away the fear, but more to be like with the children in that moment. Yeah. Nice. Thanks.
Yeah. In fact, it might, just taking on from your point, it would be nice as teachers, we come into the classroom and say that we will have some tests along the way, and we will have spot quizzes and stuff like that. And we can just make it very first person and say, I don't expect all of us to get 90 marks and 95 marks and 80 marks and 70 marks and so on. We will all have different marks, and that's perfectly fine. But what I want from this classroom, I want all of you to try up to 100% of what you can try. Okay, so if we just keep the entire marking system itself, as a teacher, our marking system for us is, can I create a classroom of triers? That's it. If I can score 95 marks as a teacher on, I got all my 20 kids to try up to 95, 100% of what they can try, I've done my job. Rest of it, where they discover their success, they would have learned an extremely valuable life lesson, and that's all they need to learn in a classroom. Math, it's okay. I mean, some kids will do good in math. Some kids might not be very, good in math. That's perfectly fine. And we don't want to judge them. We don't particularly want to tell them some of the kids as intelligence, and that equating math with intelligence is another big problem we should get rid of. And as math teachers, because we have agency, we might be biased to thinking like that. And it's even more difficult for us to get rid of that bias as compared to people who are not math teachers, who might be quite ambivalent and say, I don't get math, so what? I mean, I'm very good in sports, I'm very good in art, I'm very good in swimming. I could be good in 20 different things. It doesn't really matter whether I can do 73 times 21 or not. Yeah. Santosh, you want to go ahead?
Yes. Actually, there were 3 questions, and
Yeah.
on the screen, the answer of 2 and 3 are pasted same. Actually, third answer was not this.
Okay.
I have written other things. If you want to
We
share,
can do one thing. You can focus. That is my mistake. So it's quite nice. So it's a failure I learned from, and the next time I will bring the third question separately. That's my mistake. I pasted the third question's
no issue.
answer. Take the first and the second.
First, actually, I have written what I had done in my class. Actually, for students, fraction is very difficult topic. They take time to understand this. My focus is, once they understood the concept of half, 1/3, and 1/4, then they can understand easily. Actually, they don't know the unit fraction. I make a concept clear of unit fraction, and then move to other comparison, 1/3, half, and 1/4. When they understood all things about fractions, then I ask them about whole. Here I have mentioned 4/4 and 8/8. For them, if you simplify, both are whole. If they answer ki my whole is small and my whole is big, then they can understand 4/4. When the my whole is small, then obviously it will be smaller. And if I take both same and I make 4/4 and 8/8, then clearly 4/4 will be larger. Am I able to clear?
Yeah.
Means clarity of concept and visualization of fractions make them understand the topic very clearly.
Yeah. Yeah.
And second question was, how do you plan? It's my plan. I have not tried in the class. I will try this.
Okay.
And for third, what thoughts do you have for increasing conceptual or problem solving? It was more hands-on activities, more maths talk to build thinking in classroom and encourage students to explain their thinking. And nowadays in our department, there are mission mathematics classes, and on each topic there is a question of the day. I think that is very successful. In our last academic session, when a student is given home tasks only for one question, then they do well. And inquiry based teaching learning, group work, And one approach, Kamal approach, we have tried in our Mission Bunyad classes. I think I have already mentioned. It's combined activities for maximized learning. Here, class start with Ganitiye Baatcheet, then discussion in large group, and then dividing the whole class in small groups, then individual attention.
Very nice.
It helps students to see the relevance and applicability of maths in their daily life. We try to take example from their life. They are asked and they try, and it affects very much for understanding, conceptual understanding.
Nice.
That's all for my side.
Thank you, Santosh, for sharing all of that. Very, very helpful and very useful too.
Yeah,
now
please let us know after you try out
fractals.
Fractals, yeah, on your similar triangles. Let us know how.
Yes, I will try in my
Yeah.
class, and
Yeah,
I
let
will
us know.
share with you.
Yeah, thank you.
Thank you.
Yeah. So today's questions, we will write it down on the WhatsApp group and we will post it there. We want each one of you to just share your thoughts. Okay. So let's not wait for somebody else who is going to share, and let's not be shy of sharing. It's what we want is we want each one of us to give it a shot on any one of the three topics. Share your thought. Okay. Not necessarily on all the three. Today we spoke about negative numbers. What are your thoughts in terms of introducing negative numbers? Do you have any creative ideas of introducing negative numbers? What do you do? And how did you meet with some success or lack of it in that particular trying? And what was the response? And how did you modify? How did you try the next year? So any kind of thought sharing on that will be very useful. And similarly, Pascal's triangle, how can we incorporate it in our homeworks, in our class discovery process? There are so many properties inside a Pascal's triangle, and we can slowly discover each one of these things. Do you plan to implement that in your classroom? And if so, how? And the third one we spoke about, which is teaching our children how to fail. What are some of the adjustments you are planning to make to the way you think about a class or about a child or about a group of children? And how can we bring about a culture of trying hard and not necessarily measuring it as whether it is successful or not? Yeah. Okay, we are bang on time. There are a couple of comments. Yeah, Lata, convergent is more direct question, and the other one gives us an opportunity to think. That's one way to describe it. The beautiful thing which happens in divergent thinking when there are not enough variables is you slowly try and discover what is going on. See, the process of discovery, we should all keep remembering. The process of discovery is critically important in mathematics. Okay, and we should give our classrooms, we over to our children to give them an opportunity to try without judging them and providing them a safe environment. And they should have the trust to try, and doesn't matter whether the answer comes out or not. Okay, thank you very much. If there are any questions, we can take it now. If not, we can bring the session to a close. We will post the questions on the WhatsApp group, and we'll meet you in exactly 14 days from now, which will be the 21st.
I have an observation on my, I would like to share something over here. You were just talking about failure, success and all those things. So this thought was pondering around in my mind. And Mr. Sendal also added that it is not right. It will be right if you set different expectations for each child. So rather than we setting up the expectation for each child, when the child is, matured enough to understand its own weakness and its own strength, can the child not be allowed to set its own expectation? And when it sets the expectation for itself, I think it will work towards it without any kind of motivation or without any kind of external influence.
Yeah.
So, and once it reaches, and further it can be pushed to reach the higher level. I mean, I don't think you always have to set things for students. See, as a teacher, first thing what we try to do is we carry this notion that we are the one who do everything for those kids. It's not. There are so many things that kids can do all by themselves. We just need to be there beside them, watch whether they are using the right path. That's all.
Yeah. Yeah. Good suggestion, Lata. Very good suggestion. And I also particularly liked what you went through, which is called metacognition, which is thinking about our thoughts. You started by saying that the children are smart and children are mature enough to. I quite like you quickly corrected the smart to mature. Okay, we don't want to label necessarily any child, and that's metacognition, which you did online. I could see you in the recording, we will see. The starts and then you switch to mature, which I really like. Thank you, Lata.
Thank you so much.
There is one more comment by Sendil. Lata, bang on. Yeah, absolutely. That's it. Yeah. Yeah. Because equalizing kids, no, is a very, very problematic thing, which is why rank and marks and all that, we have to really, really carefully think about all these things. We don't want to equalize anything. Okay. What we want is an equal amount of opportunity. What we want is an equal amount of trying, equal amount of environment. Okay. The performance will all flower in some direction or the other. We don't want to equalize every tiny little classroom and make everybody get 100 marks. Simply not the purpose of a teacher. All right. Is on 21st. I wish the session was on 22nd, then we could have taken a pie. But 21st of July is when the session would be. Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank
Bye.
you.
Bye.